Hey everyone, today I'm going to take you through Infrahub's solution for AI data centers. We are going to show you how you can take a design-driven network automation approach to deploy large-scale AI data center fabrics using Infrahub. We're going to deploy a standardized 5-stage Clos topology. We're going to start off from defining high-level design inputs, which we will use to generate all of the infrastructure that we need up to the point where our device configurations and our cabling plans are ready to deploy the fabric. In the last step, we're also going to show you how you can perform day two operations, such as extending the fabric by adding a new rack without rebuilding the whole fabric. So what do we mean when we talk about design definition? The high-level design captures the intent of what we want to deploy, not necessarily how we want to deploy it. Or in our example today, we are going to define what our fabric looks like. In this case, it will be a definition of how many super spine switches we want to add to the fabric and what the specific devices are that we want to use for our super spines. In that fabric, we are going to define which pods it should contain. And within each pod, we're going to define how many spines need to be deployed and what specific type of spine switch we want to use. We will also be adding the racks that we want to deploy into the pod with the specific devices that need to be deployed and what type of rack it is going to be. Then from that high-level definition, we will generate the complete 5-stage Clos fabric, including the cabling, the IP addresses, and all of the data that we need to define the IP under. So let's switch over to Infrahub. We have a high-level design objects. As you can see, there's no devices defined yet. Everything is completely empty. What is already there though is our high-level design of what we want to capture. First of all, we have defined a hall in which our fabric is going to be deployed. So if we look at the high-level design of the fabric, then we can see that we have already defined a fabric A object. The fabric A object defines what we want to deploy within the fabric layer. Here we can see that we have defined that we want to deploy 6 super spine switches, the interface cabling method that we want to use on those spine switches, and the interface cabling method that we want to use towards the spine switches in the pods. We've also selected a device template that we want to use for the super spine switches. That device template contains specific characteristics of the devices that we want to use, such as the interface layout. Here we can see the many interfaces we are going to have on the super spine switch, and each of them has a specific role. Here we see the spine role, which is an indication that this interface can be used to connect the super spine switch to the spine layer. In the fabric, we have also defined the pods that we want to deploy as part of this fabric. We can see 3 pods here, which each have their specific role. Again, we can see, for example, pod A1, which has the role fabric, and we can see pod A2, which has the role CPU, in which we are going to deploy our compute. If we open such a pod, we can see that within that pod, we capture how many spine switches we want to deploy, the interface sorting methods or the interface cabling methods that we want to use to connect them to the super spine layer, and the leaves within the rack. Then we also define a specific device template that we want to use for those spine switches, which also contain their interface layout with specific roles. Here we can see, for example, an interface with a leaf role, which is an indication that this interface can be used to connect it to leaf switches within the rack. And we have interfaces with the super spine role, which can be used to connect the spine switch to the super spine switches. Within each pod, we also have the definition of the racks that we want to deploy. For example, here we have a specific rack, which is going to be of type compute, indicating that this rack is going to contain our .gpu cluster. We define an amount of leaf switches that we want to deploy within this rack, in this case 2, and we see the device template that we want to use for the leaf switch. So the leaf switch, again, has its own layout in terms of interfaces. So we can see here an interface that has a role server, indicating that this is an interface that we can use to connect GPUs. And we have interfaces with the role spine, which is an indication that this interface can be used to connect the leaf up to the spine layer. So from this high-level definition, we are going to deploy the full AI data center fabric. Within Infrahub, the first thing you do before you start making changes is creating a new branch. So we will create a branch called deploy fabric A. Once this branch is created, we can start the actual generation process. For that, we're going to go to actions and then generator definitions. We can see here that there is a fabric generator available to us. So we will be opening the fabric generator and we're going to click on run. In this case, we only want to generate fabric A, so we're going to select the specific target and start the generator. The generator has now started, and we can see that by looking at the activity icon in the top right. If we click on that, we will see that there's multiple tasks running in the background. We can see here that a generator has triggered to do the deployment of fabric A. This fabric generator by itself will trigger other specific tasks and actions to run within the system. So let's wait a bit until it's completely finished. Our generators have finished and we can see that the fabric has been fully and successfully generated. If we go and look at the devices that exist into the system right now, we can see that there have been 25 devices created. If you look at a device, we can see that they have received a IP address allocation. They have been positioned in the correct pod, and we see that the interface is created as well. Some of these interfaces have the status active and have been connected to other interfaces on other devices. For example, we can look at Ethernet 19 here, which has a specific IP address. It's a /31, so a point-to-point connection. It has a specific link connected to that interface. If we go to that link, we can see that the other side of the link is connecting us to a spine switch. In this case, spine switch in port A3 number 4 on Ethernet 28, which by itself has its own configuration data. If we look at the leaf switch, for example, we can see exactly the same. It has a loopback IP address allocated. It has been positioned in the correct rack, in the correct pot. And we can look at the interfaces on this particular leaf switch. For example, we see here an interface, Ethernet 27, which is connected to a specific spine switch in the pot, in this case, spine switch 1 for pot A2 interface Ethernet 3. Also, we can have a look at the IPAM data. We can see that specific IP prefixes have been created by our generator. So we can see that a /16 was allocated for the fabric. And within that /16, we can see that multiple prefixes have been created. For example, the top /28 here, which is used for the loopbacks, the super spine switches, in these two /19s, which have been allocated for the two specific pods that we have created. We will also see that multiple resource managers have been created, which can be used by the generator to allocate specific IP addresses to resources within our fabric. So our fabric has now been generated in a branch, and we are going to open a proposed change to merge the changes within this branch into the main branch of Infrahub. So let's create a proposed change. Think of a proposed change as a pull request in a typical Git workflow. So we have opened our proposed change. And what this is going to do in the backend is spin up Infrahub CI pipeline as part of this proposed change. we can see that Infrahub is going to generate us a diff of what changes have been made within this branch compared to the main branch. For example, we can see all of the IP address allocations it did, all of the prefixes that it has created, all of the devices that were added by the generator, a full diff of the changes it has done. As part of the CI pipeline, Infrahub is going to validate all of our data, but it's also going to start the generation process of artifacts. Artifacts are the device configurations that we have defined that we want to be generated for the devices within this fabric, but also the cabling plan. So the CI pipeline is now done. We can see that everything has been correctly validated and that the artifacts have been properly generated. So if we look here at specific artifacts, we can see that a startup configuration has been generated for a specific leaf switch, and we can see a diff of that result. As there was no configuration before, the previous state is empty and the new state is the configuration that was generated for this particular switch. Configuration for the interfaces, the OSPF underlay, etc., etc. We can see all of the diffs that were generated for all of the other startup configurations of all the other devices, but also the cabling plan diff. We can also look at them in the UI of Infrahub itself. So for example, if we navigate to the fabric here, we can see that there is now an artifact attached to this fabric, which is the cabling plan. And we can now see the cabling plan fully rendered as a proper table. We can download the fabric cabling plan from here so that we can also send it, for example, to our cabling team so they can start cabling the data center. If we look at the devices, they will also have a specific artifact now containing their startup configuration, which can also be downloaded here and copied up to the device. But in a typical automation workflow, these configurations will be consumed through Infrahab's API to start the deployment process. Let's navigate back to our proposed change, and we're going to assume that everything is okay at this stage and merge the change into the main branch. So the merge operation has now started. It's quite a large data change, so it's going to take a few seconds, and the branch has now been merged to main, meaning that all of the data that we have now generated is also going to be available within the main branch. So what have we seen? We took a design-driven network automation approach to start from a high-level definition of what our fabric should look like, and then from there we generated the complete infrastructure for our fabric up to the point where we have the device configuration artifacts that we can deploy onto the infrastructure, including a full cabling plan. We defined at the high level what our fabric layout would look like and what it should contain, the 6 super spine switches and which templates we wanted to use for the super spines. We defined which pods we wanted to be deployed as part of our fabric, in which we defined how many spine switches we wanted to deploy within each pod, which role each pod should have, and which switch template we would use. Then within those pods, we have defined the racks and what should be contained within those racks. Then we triggered off a generator, which is going to be the logic that translates our high-level design into the actual infrastructure that needs to be deployed. In this case, we deployed 25 devices. We saw that we created the hierarchical IP pools, all of the interfaces, the cabling, all of the IP addresses for the devices, including the loopback and all of the point-to-point links. And at the end, we were able to generate startup configurations and a cabling plan. In Infrahub, we use generators for this process. At a high level, we divided our high-level design into multiple layers, and each generator was responsible to implement a specific part of that generator. So we had the fabric generator, which we started off manually, which in the end triggered the pod generator to run when it was done. And once the pod generator ran, we automatically triggered the rack generator to deploy their specific racks. At the end, we saw how the proposed change allowed us to merge the changes that the generator had created into the main branch. And as part of that process, we triggered the CI pipeline, which generated the specific device configurations and the cabling plan. In the last step, we want to show you how you can perform day 2 operations using such a design-driven network automation approach. In the previous step, which was on our day 0, we defined the initial fabric, but over time we realized that this fabric needs to be extended with new capacity. So we are going to be adding a rack to this existing fabric and show how we can use those same generators to deploy that rack into the existing fabric without modifying the existing overall high-level design. So we will be creating a new branch in which we are going to define a new rack for pod A2, and we're going to define the amount of switches that we want to be deploying. We're going to run the rack generator, which in the end should create 2 new leaf devices for us with 8 new links that are going to be connected to the existing spine switches. New /31 subnets will be allocated to connect the point-to-point links between the leaves and the spines. And in the end, we should get new startup configurations for the new leaf switches and an update to the configurations of the existing spine switches to which the leaves will be connected. And we should also see that our cabling plan gets updated. So let's navigate back to Infrahub. Let's start by creating a new branch. Let's navigate to the racks and create a new rack in our branch. We are going to create a rack of rack type compute. Then we is going to be rack A35. We're going to give it an index, set the amount of leaf switches to 2. We'll be selecting the device template that we want to use, in this case, the leaf switch for compute type, and we will be selecting what that this rack needs to be deployed to. It is going to be part of column A1, and we're going to add the rack screw. Okay, the rack has now been created, and we can start off the generator. So let's move back to our generator definitions, and this time we can use the rack generator for its purpose. We're going to select our new rack as the target and start the generator. We can now see that the tasks have started in the background. Let's wait until generator finishes. Okay, the rack generator is finished. Let's move back to our new rack. And we can see that it has now 2 devices that have been added by the generator. We switch 1 and we switch 2. If we open such a device, we can see that a loopback GP address has been allocated. It has been positioned within the right rack within the correct slot. If we look at the interfaces, we can see that implement 27, 28, 29, and 30 have been used to connect the device into the existing spine switches within the A3 plot. Let's open a new propose change to merge these changes to the main branch. The CI pipeline is going to kick in, which will trigger regeneration generation of artifacts. If we look at the data diff, we can see that 2 new devices have been added, new IP addresses have been allocated, and new IP prefixes have been created. We can see that new links or connections have been created, and all of the other relevant changes. We check the CI pipeline. Fact generation is still in progress. And now we can see the updated artifacts. 2 new artifacts have been generated, one for each leaf switch, their startup configuration. And we can see that the configurations of the existing spine switches have been updated to host the connection towards the new leaf switches in the new rack that we have created. You can also see that the fabric cable plan has been updated with the new connections to host the leaf switches. Quick recap. We have shown you how Infrahub's solution for AI data centers allows you to build large-scale AI data center fabrics using a design-driven network automation approach. We defined in a high-level design what we want our data center fabric to look like. We defined fabric objects, pod objects, and rack objects. We then used generators to build the day zero infrastructure up to the point where we could generate the full device configurations for all of the infrastructure as well as a cabling plan. Then we performed a D2 operation where we extended the existing fabric by adding new capacity through adding a new rack, where we used a generator to generate the new leaf switches that were connected into the existing fabric, up to the point where we could also generate new configurations and updated the existing configurations of the spine switches so that we could automatically deploy the configurations to those devices as well. If you want to try out this solution by yourself, you can find the 2 links here. So in the docs.infrahub.app documentation website, under solutions, you can find the complete documentation of this AI data center solution. Here's also the link to the GitHub repository that contains all of the resources that we use today. Thank you.